Hey guys, in this video we're going to talk about EIGRP fast reroute. Now fast reroute is actually a pretty cool feature in EIGRP. Before we go into it, what I want to do is I actually want to just spend some time talking about how EIGRP essentially works on its own. So let's say that we have an EIGRP adjacency. In fact, this is how our network is currently set up. So we have an EIGRP adjacency between routers 1, 2, 3, 4, and 5. And router 1 sees that he has an equal cost path going towards 10, 24, 35, right? Because both router 5 and router 4 have those interfaces that are being injected into EIGRP. This interface is actually shut down, so just kind of ignore that it's even there. So let's talk about how this works. So router 5 calculates a feasible distance toward this network, right? And of course, it's directly connected. Then, let me pick a different color. Then router 5 advertises this prefix over to router 3, and he gives it his reported distance. He also gives it some values that we call the vector metric, right? So he's going to give it the bandwidth. He's going to give it some other pieces, right? Because when we look at the composite metric, let me just actually show you here. Let's say show IP route 10.24.35.0/24. Sorry, that's not what I'm looking for. Show IP EIGRP topology and look at the same route. Right? We have this vector metric, right? And so this vector metric is made up of the minimum bandwidth, the total delay, the reliability, the load. And so we have these various different vector metric pieces. And so some of these pieces are coming over from router 5, right? Because we have to know what the minimum bandwidth is and the total delay is on the links. So router 5 has to send over these values in order for router 3 to understand them and know, okay, so far I have the minimum bandwidth of 10,000. So far, I have this minimum value in picoseconds as my delay. So once this route heads over to router 3 then says, okay, what is my minimum bandwidth, and let's update that metric, right? So if the minimum bandwidth is something on router 3, we're going to use that value. If the minimum bandwidth is something on router 5, we'll use that value. Bottom line is that now router 3 calculates his own feasible distance. But then what does router 3 do with that feasible distance? Well, he sends that feasible distance on in the form of a reported distance going to router 3, along with some of these vector metric values, right? So router 3 says, hey, so far the lowest bandwidth I have on the link is 10,000, the total delay is this, etc., XYZ. So then router 1 says, okay, thank you very much. I'm going to calculate my own feasible distance. Well, the same process happens in this direction, right? So router 4 does the same exact thing, and ultimately we have a feasible distance over here on router 1. Now, by default, right now, these guys are going to be equal. So router 1 sees that he can send traffic either to router 3, or he can send traffic either to router 2 in order to reach this prefix. But now let's say that something happens where router 5 is not a successor, right? Because this is what we would call our best next hop, right? So by default, if we have a successor, this successor is going to go into the rib, right? If we have more than one successor, so let's just say successor times 2, we will have 2 successors in the routing table. So when we have an equal cost metric, let's say show IP route EIGRP, when we have an equal metric, we're going to add both of those successor routes into the routing table, right? But it goes further than that, because these guys, when they're added into the routing table and they're chosen as next hops, they ultimately end up in the Ceph table. And it's ultimately Ceph's responsibility to actually forward the traffic based on the information in the rib, based on the MAC address table, etc. So really what we're concerned with is how many valid next hops are we going to be adding into the Ceph table. And this is where fast reroute actually comes in and improves on the already pretty good EIGRP functions. So let's say that we don't have a successor, but we have a feasible successor. Okay, so right now, let's say that router 2 is the successor, so this is our primary path, and router 3 is going to be our feasible successor, or our second path. What happens to the feasible successor? The feasible successor only lives in the topology table, right? The feasible successor in EIGRP does not ever make the rib, and he certainly does not ever make the Ceph table. He only ever lives in the EIGRP topology table. And should the successor go away, so should we lose this link, what happens is this guy actually needs to recalculate. before we pop it into the rib and before ultimately he makes us trip over to the Ceph table. And so this actually does take a little bit of time. I mean, to us, to human beings, it's not really that long, but to traffic that needs to get there, literally the you know, voice traffic, for example, needs to get there the very second that packet is essentially created. I mean, you speak and it has to get there to the other side, right? So this could sometimes cause an issue that we actually have to recalculate that feasible successor, ensure that it's loop free, and then go ahead and pop it in as the successor and pop it into the rib. What fast reroute does, fast reroute pre-calculates. And this is what we call a LFA, or loop-free alternative. So what it does is it goes in and it pre-calculates that feasible successor, and it actually populates it into the Ceph as a backup route. So now it's not actually just living in the topology table, it actually ends up in our Ceph table ready to go. The minute we lose an adjacency, boom, we can just go ahead and start using that backup route because he's already there in the Ceph table, right? So let's take a look at this. Let's just poke around for a minute here. So let's say show IP Ceph, and let's pick on this route here. If I pop this guy in, you'll notice that I have two next hops, right? One goes to router 2, so 10.1.2.2, and one goes to router 3, 10.1.3.3. So this is again because we have two successors, right? If I say show IP EIGRP topology table, and we see these routes here, we have two successors. They're two equally cost paths, right? So we're multipathing. But let's change this. And the reason why I kind of brought you through how EIGRP works on its own is because I wanted you to kind of see how this works and what we're going to tweak. So let's go ahead. This by default is going to be 10,000. So we're going to make it 9,950. So we're just going to decrease the bandwidth by 50. All right, so let's go do that. So we'll say interface Ethernet 02. We're going to say bandwidth, we can spell 9950. Now, let's give EIGRP a minute, and let's say show IP route, EIGRP, and let's see if we've removed the second route. And we have, right? So now, if I go in and I take a look at this, this is my only valid next path. This is my successor. Let's take a look at the topology table. Let's say show IP EIGRP topology, and we can see that this guy is still my successor, and this guy has now become my feasible successor. Well, why is it my feasible successor? Well, because we are meeting the feasibility condition, right? So this is actually exactly what I was trying to say. So let's say show IP Ceph, and look at this route. Before we had them both in the Ceph table, and now we only have one. So if we go ahead and we lose that successor, so let me draw this in here. This successor now is router 2, the feasible successor is router 3, but the problem is that if we lose this guy here, it's not essentially going to be instant. Yes, we have a second path that EIGRP can use when he needs to. By the way, I made a mistake here. I erased the interfaces on you. This is gig 1, this is gig 2. So when we look at this here, this is actually our successor, and this here should be our feasible successor. So, and you can see the IP addresses here. This is router 3, this is router 2. So now that we've made that bandwidth here 9950, we have this guy as our feasible successor, and this guy here is our successor. What happens if we lose the successor? Well, now we have to go ahead and again recalculate that metric to the feasible successor. This is where fast reroute comes in. Okay, so let's go ahead and let's actually take a look at fast reroute, and let's actually poke around at some of the config. All right, so let's say do shall run section router EIGRP. We're going to do this strictly by going into the CLI and taking a look at the config options. So I'm going to say fast reroute, and I'm going to hit the question mark. Let's take a look at the load sharing option right off the bat. That's our first option here. Now, when we have a primary path, okay, and it's what we call an ECMP, or an equal cost multipath, okay, if we have multiple LFAs or loop-free alternatives, okay, there is an opportunity there that networks may be distributed across equal LFAs. So if you have router 1 and you have multiple LFAs, there's a chance that you may actually distribute across equal cost LFAs, right? That may be an issue for you. So you can go ahead and you can disable this if you so choose. And you would do that by saying fast reroute, and then you would say load sharing. Well, let me click back in the CLI. Load sharing, and then you would just simply say disabled. Okay, now I'm going to make some what may seem as some weird configuration changes. I'm not really meaning to light this up in best practice. I'm just explaining to you the features. So this is one thing you may want to disable. You may want to disable that default load sharing across your multiple LFAs, if you will. Now I want to also talk about the tie break for a second, okay? The tie break is essentially a way that fast reroute essentially uses to calculate what he's actually going to use as an LFA. So let me actually give myself a bunch of whiteboard space here, and I'll write in essentially what they are. They're not going to be in specific order. I'll show you what the order is in just one second. So you have the first one is what we call the interface disjoint. Brain didn't function there for a minute. Now what this basically does is this eliminates LFAs. LFAs. Okay, this eliminates LFAs that share an outgoing interface. So if you're gonna have multiple LFAs and you have two LFAs that are essentially using the same interface, this will essentially discard those LFAs. Okay, then you have the line card, the disjoint, which essentially does the same exact thing, but for the line card. So this is the same thing here, except it's the line card. Right? Makes sense. Because, you know, what if you're running a 6500 or an old 4500 or who cares what you're running, and you have multiple loop-free alternatives, even though that doesn't even say LFA, we'll put it up here, right? And you're running multiple LFAs, right? And you're sharing a line card. If you drop the line card, you drop both of those, you know, backup routes, and that really doesn't help you, right? So then we have the lowest repair, and I want to say this is called path, lowest repair path. And what this does is this drops or eliminates high metric LFAs. So if you have a loop-free alternatives and they have a very high metric, the lowest repair path is going to essentially remove what that it's going to remove those higher metric values. Last one is you have the SRLG, and I think that stands for Shared Risk Link Group? Yeah, link group. Took me a minute. Okay, and what this essentially does is you can have your interfaces in a grouping, and this will actually change. This will actually, this will not use the interfaces that are in the same group for the same LFA for those same prefixes. So you can group different interfaces, and if they're in the same group, it won't use them both at the same time for the same loop-free alternative going to that path, because it knows if you lose one interface, you may also lose the other one because they're in the same grouping. And this is more of an admin thing that you would go back in and you would set. And you can change essentially where the you know, what the values are. Okay, so let's go back in here, config t do show run section router EIGRP. We'll go back into our topology base, and I'll say fast reroute, and here's where we can say tiebreaker, and here's where these tiebreakers are. So we have the interface, the line card, the lowest backup path. Sorry about that, I forgot the word backup. I said repair. Well, it's close enough. And then you have the shared link risk group, right? Now, if we say do show run all section router EIGRP, you can see what these values are set at by default. So you can see here, this is the actual order. So the shared link group is going to be the first one that's chosen, then the interface, then the lowest backup, then the line card. So they're actually in reverse order. And here's the priority. So if you want to change these, you would do something like this. And then you may want this set to maybe you want this set to 25, for example. So do show run all section router EIGRP. This guy would then be chosen after interface. You could rearrange these in any way that you want, any way that's essentially more important to you. You could go ahead and you could use, right? So do show run section router EIGRP. Now, how do we actually enable fast reroute, right? We have the load sharing disabled. We're going to go ahead and we're going to say that we want the interface to be used first because the shared link shared risk link group rather, we're not going to use. We want that after essentially the interface. In order to turn on fast reroute, all we need to do is say per prefix. Okay. Now we can say all, or we can say we can set up a route map pointing to just the prefixes. So if I only want fast reroute turned on for a single prefix, I could say route map and then say FRR, you know, something along those lines. And as long as the routes that I'm looking to turn on fast reroute for are in that route map, I'll be able to use it. But for now, I'm just going to go ahead and say all. Okay. Now at this point, we can see that we have it says a BFD session created, but if I say show BFD and I say neighbors, you can see I actually don't have any BFD neighbors. Show BFD summary. I don't have anything going on. So this is just this is a back-end BFD session that we don't really have any control over, that we don't really administer in any way, shape, or form. Okay. But now what I want to do is say show IP route EIGRP. Let's take a look at this. Do we still have a single route in our routing table? Yes, we do. It points to router 2. Let's say show IP EIGRP topology. Do we still have a feasible successor? Yes, we do. Let's say show IP Ceph and actually look at this prefix and see what changes we've made to our Ceph table. Show IP Ceph JP. Take a look at this. Now we actually have a repair. But for some reason my mind said backup, but now we have a repair path, and it says attached next hop 10.1.3.3. So now because we have fast reroute enabled, we actually have the ability to use a repair route that's already added into our Ceph table. So another thing that we can do to actually verify this is we can say show IP EIGRP topology table, and then if we hit the question mark, you'll actually see that we have an FRR option here, and this is basically going to say show us all of the FRR, or show the fast reroute entries in our topology table. And if you look at this, it tells us here that this is actually a loop-free alternative. Right? So this is actually, it's actually a really, really cool feature, very, very easy to set up. And again, we can see it, we can verify it in our Ceph table, we can verify it in the topology table. Now, one last thing I want to show you here is I was showing you, let's say show run section router EIGRP. I was showing you how we can use these tiebreakers, right? And I pointed out the shared risk link group. Now, how do we change that? How do we go in and administratively say, hey, I want to add interfaces or change interfaces in specific groups? Well, if you go under the interface, you can say SRLG, and here you can say the group ID, and then you can go ahead and you can assign these various different groups to those particular interfaces. I'm going to be honest, I generally don't mess with it. Usually when I use this, I kind of set this to a different, you know, the highest option, and I leave the rest set to the default, because essentially the interface, the line card, those are usually the most important to me. So do show run all section router EIGRP. And let's go down. So the line card and the interface are usually the most important to me. I usually don't care all that much with the lowest cost, although, you know, it is somewhere in there. It's usually number 3 for me, but I definitely don't want, you know, if I'm sharing an interface or sharing a line card, I definitely don't want a loop-free alternative. So this is how we set up fast reroute. Sorry for the little bit of a long video, but I wanted to make sure you guys understood this. Again, really cool feature, really easy to set up. Hope you guys enjoyed it.